Hello and welcome in today's video. In today's video we are going to look at how to solve a linear programming problem by the method of a simplex method. And this is a linear program that you are given here, which is maximize z equal to 5x plus 7y, which is subject to these constraints. The first one is 2x plus 3y less than or equal to 13. The second constraint is 3x plus 2y less than or equal to 12. And now the non-negativity constraint, which is x greater than or equal to y, same as y greater than or equal to 0. So the first thing before you can solve this by simplex method is to convert the system into standard form. Convert the LPP into standard form. What do we mean by the standard form? So in this particular case, you introduce what we call the slack variables. And the standard form of this will be maximize z, which is equals to 5x plus 7y. Then you minus the slack variables. So in this particular case, you notice that each and every constant has its respective slack variable. So in this particular case, we need two slack variables, one for the first inequality here and the second one for the second inequality. The purpose of these slack variables is to convert these inequalities into equalities or into equations. So for this, we're going to add 0s1 minus 0s2, which would imply that this would be maximized, because either way it has to be an equation. If you send this to the other side or to the left hand side of this equation, it will be z minus 5x minus 7y plus 0s1 plus 0s2, and this is subject to, so the first one, it will be 2x plus 3y plus s1, which is equals 13. Can see we've converted that into an equation or into an equality. The next one will be 3x plus 2y plus s2, which is equals 12. And all these, that is a variable x, y, together with these slack variables, they should be greater than or equal to 0. That is the non-negative or the non-negativity constraints. So the next thing, after we've converted this into standard form, it is we come up with the simplex table. And in the simplex table, this is what you're going to have. So we have a basic variable. So after the basic variable, we have the coefficients of, we have x, y, and also the slack variable, which is s1 and s2. Then from there, we shall have the right hand side of these equations that are in this standard form of the LPP. Then afterwards, you have the ratio. I think that one is visible enough. So the first basic variable is our objective function, which is z, and z is to maximize, the objective is to maximize this z subject to these constraints. So next, it is now the coefficients of, from this particular part here, we can have the coefficient of x, y, s1 and s2. So the coefficient of s1, remember this is equated to 0 because an equation, because we send this to the other side. So the coefficient of x here is negative 5. So we're gonna put negative 5 there. The coefficient of y is negative 7. The coefficient of s1 is 0. The coefficient of s2 is 0 as well. And what we have on the right hand side is 0. So the next basic variable, it is now our s1. And s1 corresponds to this particular equation here, which is a first constraint. So in this case, we have the coefficient of x being 2, the coefficient of y being 3, the coefficient of s1 being 1, and the coefficient of s2, there is no s2 in the first equation, so you put a 0, and the right hand side is 13. The next one is S2, and S2 is a slack variable that corresponds to the second equation. So what is the coefficient of x there? The coefficient of x there is 3. The coefficient of y is 2. The coefficient of S1 is 0. And the coefficient of S2 is 1. And what we have on the right hand side is 12. And now these will form the first simplex table. So to construct the next simplex table, we use iteration. We perform iterations. But before we look at that, we have to identify what we call the pivotal column and also the pivotal row, and also identify the pivotal element. So you go back to your objective here, which is Z, and in the Z row you identify the most negative value. That is, these coefficients, you identify the most negative value, and by the look of it you will observe that -7 is the most negative value. And now this becomes our pivotal column. That is, members in this particular column will be the pivotal column members. So after identifying the pivotal column, the next is we find the ratios. That is, you take what is on the right hand side divided by what is in the pivotal column. Like for example, in row 1, the right hand side is 0. So 0 divided by -7 is going to give us 0. 13 divided by 3, just have to leave it the 80s, which is 13/3. Next it is 12 divided by 2, which is going to give us 6. And when you look at these two, you will notice that we have 0, 13/3 and 6. So for you to be able to identify the pivotal row, you consider these values that are greater than 0, or the positive values that are greater than 0, and check the list of the values. So for example, if you look at 13/3 and 6, you notice that 13 is the smallest. 13/3 is the smallest. Now this means that these will be the pivotal row. These will be the pivotal row. So where these pivotal row and the pivotal column are intersecting, that would be the pivotal element. So in this case, you can write that this is the pivotal element. Pivotal element. And from there you can be able to construct the other simplex table. So the implication here is that S1 is a leaving variable, it's the one that is going to leave the product mix, and Y is joining the product mix. So in the construction of the next simplex table, you shall have these variables, that is Z. Of course, S1 is leaving and Y is entering. You have Y. Then the next one is S2. So afterwards, for you to be able to fill in this particular row, you just divide everything here, that is all the members in the pivotal row, by the pivotal element. For example, if you divide this by 3, it is going to give us 1. If you divide this by 3, it's going to give us 2/3. And you do all that to all the members in that particular row. But in this case, we have what? 2/3. The next one is 1. 1 divided by 3, you get a third. 0 divided by 3, you get 0. The next one is 13 divided by 3. It is going to give us 13/3. And now, from this particular new row that we've constructed, we can be able to fill in the other values in the Z row and this particular row. So the mission here is that all the members in this pivotal column, they should be 0 except the pivotal element, which should be 1. So the mission is to make this entry 1, or this entry 0, sorry, and this entry 0, by performing what we call the elementary operations, row operations. So let us now construct our new Z. Remember this, we can label it row 1, this is row 2, this is row 3, this is row 4, this is row 5, and this is row 6. So we construct our new row 4 by making sure that this entry will be 0 and this entry will be 0 as well. So the most suitable operation there will be, that is row 4 will be given by, you pick row 1, which is this row, and you add it to 7 multiplied by row 5. So in that case it will make this entry 0, because you know that negative 7 plus 7 is equals 0. So what is the implication here? That this is something plus 7 multiplied by something, whereby these are the values that you're going to fill in from the row 1 and row 5. So for example, we start with negative 5, you put negative 5 there, it is in row 1, and the next one is 2 over 3. So negative 5 and 2 over 3, this is going to give us negative a third. So you write negative a third there. The next one, it will be negative 7, that is this and this, negative 7 and 1 here. Of course this will be negative 7 plus 7, which is 0. You can see already you've made this entry 0. The next one, it will be 0, that is 0 and a third, which is going to give us 7 over 3. The next one is 0 and 0, which is going to give us 0. The next one is 0 and, that is this value and this value, 0 and 13 over 3, which is going to give us 91 over 3. So for the ratios, we leave them aside, because after now we perform the iteration, that is when you'll be able to fill in the ratio column. So you can see now you've filled row number 4. Row number 6, which is now this column with S2, it is filled in the same procedure. That is the operation that will reduce this entry to 0 using row number 5. It will be equal to, you can take row number 3, you minus 2 multiplied by row number 5. You can see this will be something, you minus 2 multiplied by something. So we start with 3 and 2 over 3. 3 and 2 over 3. What you get as the answer, it will be, it is going to give us 5 over 3. The next one is you pick 2 and 1, which is going to give us 0. The next one, you pick 0 and a third, which is going to give us negative 2 over 3. The next combination of this is 1 and 0. And of course 1 and 0, it is going to give us 1. The next one, it is 12 and 13 over 3. So what is going to happen there? It is going to give us 10 over 3. Then from there you go back to your row number 4. Now that is the objective Z. Now from these values that are in this particular row, you can identify the most negative value. And of course, obviously the most negative value will be that one. That is negative a third. So meaning that this becomes our pivotal column. So next we take the ratios of the right hand side and the pivotal column element. So for example, when you look at 91 over 3 divided by negative 3, this is going to give us negative 31. The next is 13 over 3 divided by 2 over 3. This is going to give us 13 over 2. This should be times 3 over 2. It's going to give us 13 over 2. The next, it is 10 over 3 divided by 5 over 3. 10 over 3 times 3 over 5 is going to give us 2. So we have obtained the ratios on the right hand side or on this particular column. So next, you look at the least positive value in this particular, or the least positive ratio which is greater than 0. So when you look at these two, we do not consider this because there is already negative. So you just consider these two. What is 13 divided by 2? Is it greater than this? And you notice that 2 is the minimum ratio here. So meaning that this will be the pivotal row. Meaning that that will be the pivotal row. So once again, this will be the pivotal element. This will be the pivotal element. And now the implication here, or the consequence here, is that it means that S2 is leaving and X is entering, or this variable X is entering, S2 is leaving the product mix. So that will guide us in the construction of the next simplex table. So the intersection of the pivotal row and the pivotal column, it is at this particular point, which is now our new pivotal element. So meaning that the implication here is that now S2 will be leaving the product mix and X is joining the product mix. So in our next table, we shall have Z, Y, and now X. You can label these row number 7. These you can label it row number 8, and this row number 9. So the new row, which is now row number 9, it is obtained by dividing the elements in all these entries in the pivotal row by the pivotal element. Like now when you divide 5 over 3 divided by 5 over 3, this is going to give us 1. 0 divided by 5 over 3, it is going to give us 0. Negative 2 over 3 divided by 5 over 3 is going to give us negative 2 over 5. But of course 1 divided by 5 over 3, this is going to give us what? 3 over 5. So still on the right hand side, 10 over 3 divided by 5 over 3 is going to give us 2. You can see we've constructed our new row number 9. So the other thing is now to make this entry 0 and this 0, just like we did with the previous table. So row number 7 will be filled as follows by the use of the elementary row operations. So this row number 7 will be given by, now we are going to use row number 4 together with the new row number 9 to make this particular entry 0. That can be done by taking row number 4, you add it to a third multiplied by row number 9, which implies that this will be something plus a third multiplied by something. I pick that operation because that is the only operation that will reduce this entry to 0. That is, if you put negative a third here and 1 here, a third is in row number 4, 1 is in row number 9. This will be a third negative plus a third, which is equals to 0. So this will be 0. The next combination, or the next entry there, it will be, you pick 0, and the next one will be 0. So obviously this will be 0 plus 0, which is equal 0. The next, it is 7 over 3 and negative 2 over 5. So 7 over 3 plus a third multiplied by negative 2 over 5. This is going to give us 11 over 5. Next, you pick 0 and 3 over 5. 0 and 3 over 5. Of course, if you multiply the two, this is going to give us 1 over 5. Now still on the right hand side, we have this entry that is in row number 4, which is 91 over 3 and 2. 91 over 3 and 2. Which is going to give us 31. So the next, it is we filling this row number 8. And row number 8 will be equal to, you find an operation that will reduce this entry to 0 using row number 9. That can be done by taking row number 5, which is now this one, you minus 2 over 3 multiplied by row number 9. So which means that this will be something minus 2 over 3 multiplied by something. So if you put 2 over 3 here, which is in row number 5, and 1 here, which is in row number 9, this entry will be 0. The next one, the combination will be, you pick 1 and 0. Of course, this is 1 minus 2 multiplied by 0, which will give us 1. The next one, it will be, you pick a third and negative 2 over 5. A third and negative 2 over 5. Negative 2 over 5 is in row number 9, which is going to give us 3 over 5. The next one, it is you take 0 and 3 over 5. You have 0 and 3 over 5 there, which is going to give us what? Negative 2 over 5. Still on the right hand side column, we have 13 over 3. 13 over 3, it goes with 2. So you put a 2 here. That is going to give us, 3. So the next thing after filling that particular table, it is to check whether you're going to proceed with the iteration. And how do you know where to stop? If you look at this row number 7, which is now the objective, you realize that we do not have a negative value here. We do not have a negative value here. So meaning that we have obtained, or we have maximized that particular problem using simplex method. Now the corresponding values of z, that is z equal to 31, y equal to 3, and x equal to 2 will be the solutions to that particular problem. So you can just conclude and say that z maximum is equal to 31. And this is when x is equals to 2 and y is equals 3. And y is equals 3. So we are able to solve that using simplex method.